So in 73, you have an nth root of a fraction. This one, we can actually simplify the numerator without a problem. So I know I'm going to get x for my numerator. My denominator then has the cube root of y squared. Now, one of the things that I like to do with nth roots when I have to rationalize is I always like to put them back in terms of fractions. By putting that back into a term of a fraction, this becomes y to the 2/3. It's easier for me to see how many more thirds I need to make a whole. How many more thirds do I need? 1. So I multiply by top by y to the 3rd, which then creates the whole that I need to fill my hole. You like that? It's good. It's good. Shut And then the numerator, I have x, y to the 3rd. But since this problem started as an nth root, what should I write my y value as? Cube root. Yep, x and then be the cube root of y. Okay. Yes, ma'am. Which one? Sure. That was what I was talking about a second ago. When you look at the one like 67, in 67, notice how they all have the exact same nth root? They're all cube roots. So if those guys are all cube roots, since they're all cube roots, the easiest thing to do to start the problem out is to write it as one giant fraction. And then in the denominator, I can combine those two. I'm going to get 27 divided by 12. Now, here I can do one of two things. I can take cube roots to the numerator, cube roots to the denominator, or if I think about it in terms of order of operations, I could in fact simplify that fraction first. So y to the 6th, y to the 12th, who wins? The 12th. So the 12th wins, and this one goes away. What becomes of the numerator? 1. The denominator becomes a 6. But the conviction that you showed when you said 6 was impressive. Oh, like the butt you guys starting, or you guys just really start to feel sorry for me. All right. So now, what is the cube root of 1? 1. What is the cube root of 27? 3 goes into 6 how many times? Hey, Devin, can you do me a favor? Do you know Aiden? You know this guy? The one that's not annoying. The one that's annoying me. Bradley. That guy? Know him? All right. And I want you to do when you come to high school, I want you to find him and knock his book out of his hand. I'm joking. What else we got? Sure, absolutely. Yeah, they can. These do tend to get a little bit easier. What's that? But I do owe you guys a video because we didn't show it the other day. Now, in this one here, you have 2 nth roots. And you wind up with x to the 3/5, x to the 4/7. So what you need to do is, well, since you have the same base, is, well, just quickly play war. If you play war with this one, we have to figure out what's larger, 3/5 or 4/7. Everybody tells me it's 3/5. So I would take the 3/5 and I would subtract 4/7 by moving that up. So I got to get a common denominator, which would be 35. So this becomes 21 minus 20, which gives me x to the 1/35. Wait, what? Did you do this and multiply top and bottom by x to the 3/7? If you did it that way, then you'd have to simplify out further. And there's nothing wrong with that. But what happens is that when you did it that way, what was your numerator when you did the 3/7 up top? Go on, yeah, you're right. Go ahead, George, say it. Shh, guys, listen up. This is a very common thing that happens, and I'm glad that she did this because I'm sure somebody else has probably seen this and you didn't know if you were right or wrong. You just didn't want to say anything. But yeah, it's exactly what you would do here because if you look at it in the denominator, you have a whole, and when you do the common denominator, that's 35/35, if you will. You would play war out. Now, the other thing you could do is realize that that is x to the 35/35 times x to the 1/35 over x. Because you can split apart the exponent because you're adding. That's another way of going about it. There's a problem on the sheet that I have for you guys tonight, excuse me, that has that little bit of a trick of splitting apart the exponent. So yeah, you can go either way with that one. Okay. What else? Let's make this stuff really crazy. I'll collect this sheet that I have for us tonight and tomorrow. This is the one that makes it fun. No, we're still working on this. We're going to add stuff to it. This is. We actually have time. I feel like yesterday. Devin, I just emailed this one over. I forgot to do it earlier. Did you get it? So this is where things can start to get rather interesting, to say the least. Did you guys all get one? Do you guys need any spares? We got all right. You know, me and counting, we didn't go very well. It's a good thing. You know, you never had to pass arithmetic to be in college. So what I want to do is I'm going to walk you through a couple of the really, really weird ones for you. For example, if I start out with number 1, I have m to the 7/4 n to the -3/2 times 2 m to the 5/4 n to the 4/3. And you've heard me say this before when we're trying to simplify monomials or simplifying anything. What we always want to start with is basically the numbers. In the numbers here, the only number that I have is what? 2. So what I'm going to do is I'm going to always write out the number first. I have a 2. And now I'm going to start using all of my exponent rules. M's. I have the same base. I have different exponents. And I'm multiplying what I do to the exponents. Add. So what is 7/4 and 5/4? 12/4. Oops. M to the 12/4, which we know as to be, okay, And then I have n to the negative 3 halves and n to the 4 thirds. Now, do I need to flip those around right away, or knowing that they're already written out, can I just add them together? You can do that. Sometimes it's a little bit of a little quicker. If I do negative 3 halves plus 4 thirds, I need a common denominator, don't I? 6. Okay. So my common denominator would be a 6, which means I have to multiply this side by 2. I just did this last hour too, and I screwed it up. You'd think I would have learned. No. Definitely. Oh, they might have had something going on. And then on the other side, what do I have to multiply it by? 2. What do you get? Negative 1/6. Good. So you have an n to the negative 1/6. So now, is that negative 1/6 happy? No. You make it sound so rude. Jeez. Oh, we found him. Hi again. Did somebody? Did you unplug us, Devin? What, Devin? I'm quiet? How am I ever quiet? I'm the loudest, craziest freak show you know. All right. Is that better? You guys need bigger speakers. I don't know why this stuff. Blah, blah, blah. Numbers, numbers. Numbers, numbers everywhere. I don't know why it keeps doing that. All right, so let's try this. Uh-oh. So if I turn mine up and turn you down, is that better? Is that any better at all? I don't know why it does this all the time. I don't want to have to wear a microphone. Should I wear a microphone? That would be annoying. Wait, didn't I just write a bunch of numbers down that disappeared? Oh, it's weird. Weird. All right. So what do I have to add to the 1/6 to create a whole? In doing this, we get our final answer, 2m cubed n to the 5/6 over 10. One thing I want you guys to notice is that in the instructions on this is kind of how I standardly write it. It says simplify. All right. Your answer should contain only positive exponents with no fractional exponents in the denominator. Huh. Huh. Sir. All right, now flip over and look at number 16. Doesn't that look pretty? All right. So what's going to happen here is mix in a little bit of this to make it look evil and awful and yeah, oh no, I don't know what to do. That kind of style. Yeah. So what is anything to the 0 power? 1. Now, that means that this value here of x to the 0, this guy just becomes times a 1. So I don't have to worry about him at all. All right. Now, the next thing that I would do is, notice you have a negative exponent in the denominator. I'd move it up right away. So we start to peel this back here. We are going to have, well, what's 2 over 4? So I have a 1/2. I have an x to the 5/4. I have an x to the 4/3. We'll play about that later. We have a y 4/3, y to 1/2, and y to the 5/3. Okay? As I start to combine my like terms, what's 4/3 and 5/3? 9/3. 9/3 is otherwise known as 3. Everybody see that? I'm here. What I'm doing here is I've got 4/3 plus 5/3 gives me 9/3, which is 3. To that 3, I have to add a 1/2, but I need to have a common denominator, which gives you 7/2. Okay? Are you all right with that? We get 7/2. So right now we have 1/2, and we have a y to the 7/2, and that's simplified out. I'm picking and choosing which variables I want to work with one at a time, because the problem itself, it looks awful to begin with, but if you break it down into smaller chunks and go piece by piece, it winds up being rather clean. So as awful as these may look, they're really not as scary as what they look like. So now you have to worry about 5/4 and 4/3. 4/3 is bigger, because that's 1 and 3, and the other one's 1.2, yes. So we have to figure out what is 4/3 subtract 5/4. So let's see. 4/3 subtract 5/4. I get a common denominator then of 12, I believe. So this becomes a 12. I have to multiply the fraction on the left by 4, fraction on the right by 3. So I get 16 minus 15 gives me an x to the 12th in the denominator. All right. But the instructions tell me, should I have a fractional exponent in my denominator? No sirree, bye. So what do I multiply the top and the bottom by to get rid of it? It's a 12. So we multiply both top and bottom. So I get yeah, this was a 1/12 here. It just didn't write out as cleanly. Yep. You multiply top and bottom by x of the 11/12, because 11/12 and 1/12 create a whole. Therefore, you get 1. Yes, sir. No, but it's kind of what math people do. As much as we don't use the alphabet, we still think it's kind of cool. It's like a descending order. It's kind of like when you're at a fancy restaurant, you start with the outermost forks and work your way in. You know, you don't know what the heck this oyster fork is for while you're using it to eat like a piece of bread. No, oyster forks. We were talking about this the other day. Oyster forks have 3 prongs on them. No, some oyster forks have 4. He uses a 1/4 less fork than you do. The four forks on a salad fork is smaller than a standard fork, and then a smaller fork, a lesser forked fork is a other fork. Time is yours. Work. I will meander about. Anyhow. I see what you're trying to do, but you just right in it. Ladies. Hey guys, real quick. You guys were the third or fourth people that have asked me this one. This is very similar to what first star was asking too. Sometimes you'll get, I'm just making numbers up here. Let's say you have x to the 5/4 in the denominator. And what you need to do is you have to rationalize the denominator. Well, the denominator is already set up as an improper fraction because the numerator is larger than the denominator. You still go through the same processes as how many more, in this case, fourths do I need to make a whole? So I would need 3 more fourths to make the whole. So I'd multiply top and bottom by x to the 3/4, which then gives me x to the 8/4, which is x squared. That's completely, totally fine. Okay? It is okay to have an improper fraction in a denominator that you're still adding to get to the next whole number. Okay? It happens. It's not a big deal. I know a couple of people have asked me that throughout the day today. I just want to make sure I stop and show you guys that. You're on the right track, but you make it the next whole number. Yeah. Oh, but it's down there just go away. Okay, you just have written it. Yeah, gotcha. What's up, guys? So what remember, guys, if you see a negative exponent, pay attention to what's actually negative. Is it just the variable next to it, the number next to it? Are there parentheses around the whole thing? Yeah, generally speaking, if one value is negative, it's just the exact value preceding the negative exponent.
Oh, and then you just. Okay, so that's, you have to write down. Yeah, okay.
Remember, when you have nth root, if it just says square root, what's the value out from the root that you don't see? Whatever, I don't have passions. What's up?